In the unending silent blackness between the stars, an emptiness so profound it defies human comprehension, countless lonely travellers drift on unseen currents. They are the forgotten debris of creation, ancient relics from the birth of worlds we will never see. For eons they wander through the cosmic ocean, their journeys measured not in years, but in epochs. Occasionally, by a chance alignment of gravitational tides, one of these silent voyages is nudged from its path. It falls, slowly at first, then with gathering speed, drawn toward the welcoming gravity of a star not its own. It is an emissary from a distant, unknown shore, a ghost crossing the interstellar void to visit our home, and in recent years our vigilant eyes upon the sky have begun to catch these fleeting apparitions. One such visitor, a whisper from a faraway stellar nursery, has brought with it a mystery so deep it forces us to question the very chemistry of creation. It is a comet designated 3I/Atlas, an interstellar object, the third of its kind ever confirmed. But this is no ordinary snowball hurtling through space. This celestial pilgrim is behaving in ways we cannot explain. It is sending us a signal, a chemical riddle from the dark, a puzzle that could rewrite our understanding of how planetary systems, including our own, are born. To unravel this enigma, we have turned our most powerful eyes, our greatest technological marvels, toward this fleeting shadow. The venerable Hubble Space Telescope, our steadfast sentinel in orbit, and the revolutionary James Webb Space Telescope, our new eye on the cosmos, have joined forces in a singular, unprecedented observation. What they have uncovered is a story of immense scale, of perplexing activity, and of a substance, methane, behaving in a manner that simply should not be possible. This is the story of a colossal alien messenger and the baffling secret it is leaking into the void. Humanity's relationship with comets is as old as civilization itself. For millennia, they were viewed not with scientific curiosity, but with a primal sense of dread and awe. They were the unexpected guests in a sky of perfect clockwork order. The planets, the sun, the moon, the steadfast stars, all moved with a comforting, predictable rhythm. But a comet was a violation of this celestial peace. It would appear without warning, a luminous smear, a celestial sword, or a hairy star, as the ancients called them, blazing across the constellations for weeks or months. Their arrival was almost universally interpreted as an omen, a divine message foretelling the death of kings, the fall of empires, the coming of plague, famine, or war. The Bayeux Tapestry, chronicling the Norman conquest of England in 1066, famously depicts the terrified court of King Harold gesturing toward the magnificent spectacle of Halley's comet. The message was clear, a great change was coming. This perception persisted for centuries, a superstition born from the profound human need to find meaning in chaos. It was not until the intellectual blossoming of the Renaissance and the Age of Enlightenment that our view began to shift. Astronomers like Tycho Brahe, through meticulous observation, demonstrated that comets were not atmospheric phenomena, but were true celestial bodies moving far beyond the moon. Then came Edmund Halley, a contemporary and friend of Isaac Newton. Using Newton's newly formulated laws of universal gravitation, Halley undertook the laborious task of calculating the orbits of dozens of previously observed comets. He noticed a remarkable pattern among the comets of 1531, 1607 and 1682. Their paths through the sky were strikingly similar. Halley made a bold, testable prediction. These were not three separate objects, but a single comet, returning to the inner solar system on a vast elliptical orbit approximately every 76 years. He prophesied its return in 1758. Halley did not live to see his prediction confirmed, but on Christmas night of that year, a German farmer and amateur astronomer spotted the returning wanderer, precisely where Halley said it would be. In that moment, the age of cometary superstition died, and the era of cometary science was born. Comets were no longer portents of doom, but celestial clockwork, bound by the same physical laws that govern the fall of an apple. They were revealed to be icy bodies, remnants from the dawn of our solar system, dirty snowballs, as astronomer Fred Whipple famously described them. These objects, hailing from the frigid outer zones, the Kuiper belt beyond Neptune and the vast spherical Oort cloud, were pristine samples of the primordial nebula from which the Sun and planets coalesced 4.6 billion years ago. Studying them was like opening a cryogenic time capsule. But all the comets we knew, from Halley to Hale-Bopp, shared one fundamental characteristic. They were ours. They were born of the same cloud of gas and dust as Earth. They were members of our solar system's family. The idea of a visitor from another star system was pure speculation, a theoretical possibility so remote it was relegated to science fiction. Then, on October 19th, 2017, everything changed. The Pan-STARRS telescope in Hawaii detected a faint point of light moving in a way that defied explanation. Its trajectory was not a closed ellipse, bound to our Sun. It was a hyperbola, a path of entry and escape. This object, later named Oumuamua, meaning scout in Hawaiian, was our first confirmed interstellar visitor. It was a watershed moment in astronomy. We were not alone in a cosmic sense. Our solar system was not an island. It was part of a galactic archipelago, and travellers could, and did, cross the immense gulfs of space between the islands. A second visitor, 2I/Borisov, was discovered in 2019, this time looking and behaving much more like a conventional comet. And then, our story's protagonist arrived. In the early days of 2023, the Asteroid Terrestrial Impact Last Alert System, a robotic survey in South Africa known as ATLAS, recorded another faint traveller on a hyperbolic path. This was 3I/Atlas, the third interstellar object. Immediately, the world's astronomical community mobilised. Here was another chance, another priceless opportunity to study a fragment of a completely different solar system, a piece of an alien world's cradle. And to do so, we aimed our two most powerful observatories at this fleeting guest, hoping to capture its secrets before it vanished forever. The Hubble Space Telescope is more than an instrument. It is an icon. For over 3 decades, it has orbited 340 miles above the Earth, floating above the distorting haze of our atmosphere. It's 2. 4-meter primary mirror has captured images that have not only redefined our cosmos, but have become part of our shared cultural heritage. The pillars of creation, the Hubble Deep Field, the eerie glow of distant nebulae, these are the masterworks of a modern technological cathedral. Hubble sees the universe primarily in visible and ultraviolet light, the same kind of light our eyes perceive, but with a clarity and depth that is impossible to achieve from the ground. It is a tireless, long-serving veteran, a symbol of human persistence, especially after its famously flawed mirror was corrected in one of the most daring space repair missions ever conceived. It has watched galaxies collide, witnessed the birth of stars, and measured the accelerating expansion of the universe. For the study of 3I/Atlas, Hubble's role was crucial. Its sharp vision could attempt to resolve the comet's core, the solid nucleus hidden within the fuzzy cloud of gas and dust known as the coma. By tracking the comet over time, Hubble could precisely measure its trajectory, confirming its interstellar origin beyond any doubt, and watch for any changes in its brightness or activity. But Hubble, for all its power, is blind to certain kinds of light. To truly understand the chemical makeup of this visitor, to read the molecular story written in its frozen heart, we needed a different kind of vision. We needed the power of infrared. Enter the James Webb Space Telescope. If Hubble is the venerable veteran, Webb is the revolutionary newcomer, a transformer of astronomical perception. Launched on Christmas Day 2021, Webb is a marvel of engineering, an origami telescope that unfolded itself 1 million miles from Earth. Its massive 6.5-meter primary mirror, composed of 18 gold-coated beryllium hexagons, is shielded from the sun's heat by a 5-layer sunshield the size of a tennis court. This shield keeps the telescope at a cryogenic temperature of -233 degrees Celsius, or 40 Kelvin. This extreme cold is not just a preference, it is an absolute necessity. Webb is designed to see the universe in infrared light, which we perceive as heat. If the telescope itself were warm, its own glow would blind its sensitive detectors, like trying to take a picture of a candle from inside a bonfire. By being so cold, and so far from Earth's thermal glare, Webb can detect the faint ancient heat from the most distant galaxies, peer through impenetrable clouds of cosmic dust to see stars being born, and, most critically for our story, analyse the chemical composition of objects in our own solar system with unprecedented sensitivity. Every molecule, every atom, vibrates and rotates, and in doing so it absorbs and emits very specific wavelengths of infrared light. This creates a unique chemical fingerprint, a barcode of existence. Webb's advanced spectrographs are designed to read these barcodes. They can tell us not just that gas is present, but precisely what gas it is, in what quantity and at what temperature. The plan was a coordinated dance of titans. Hubble would provide the wide, sharp context, the visual portrait. Webb would perform the deep chemical interrogation. Together, these two observatories, one seeing the light of stars, the other the warmth of molecules, would give us the most complete picture of an interstellar comet ever assembled. As they stared at 3I/Atlas, the first surprise was one of sheer scale. Comet nuclei are notoriously difficult to observe directly. They are among the darkest objects in the solar system, often blacker than coal, reflecting very little sunlight. Furthermore, as a comet approaches the Sun, its surface ice turns directly into gas, a process called sublimation, creating the vast, glowing coma that can stretch for tens of thousands of kilometers. Finding the tiny, solid nucleus inside this immense, obscuring cloud is like trying to spot a single dark pebble inside a dense fog bank. Using Hubble's exquisite resolution, astronomers carefully analysed the light from the very centre of 3I/Atlas's coma. By modelling how the dust and gas scattered sunlight, they could subtract the haze and isolate the faint reflection from the solid body at its heart. The results were astonishing. The nucleus of 3I/Atlas was calculated to be enormous. Typical comets from our own solar system have nuclei ranging from a few hundred metres to perhaps a few kilometres across. They are the size of a small village or a city district. The nucleus of Comet Hale-Bopp, one of the most spectacular comets of the 20th century, was a giant, estimated to be around 60 kilometres in diameter. The data from Hubble suggested that 3I/Atlas possessed a nucleus that was similarly gargantuan, a monolithic body potentially tens of kilometres in diameter. This was not a celestial snowball, it was a celestial mountain range, a substantial planetary building block adrift between the stars. Imagine a fragment of primordial material from our own solar system's formation. Now imagine that this fragment is not the size of a boulder, but the size of a continent, and that it has been journeying through the galaxy for perhaps billions of years. The sheer mass of this object was a revelation. It implied that the protoplanetary disk where it formed, the swirling disk of gas and dust around its parent star, was likely rich in material and capable of forming large bodies. This single data point provided a tantalizing clue about the environment of another, unseen solar system. It suggested that the processes that built our own world may not be unique, that other stars are also surrounded by the generous ingredients for planet formation. But this discovery of its immense size, while remarkable, was merely the prelude to the central baffling mystery. That revelation would come from Webb's infrared gaze, and it would centre on one of the simplest, most fundamental molecules in the universe, methane. As the Webb telescope focused its spectrographs on the coma of 3I/Atlas, it began to dissect the faint infrared glow of the gases being released from the comet's surface. The data streamed back to Earth, a complex spectrum of light, a squiggly line filled with peaks and valleys. To the science team, this was not just a graph, it was a message. Each peak represented the chemical fingerprint of a specific molecule glowing in the void. As expected, they saw the strong signature of water vapour. Water ice is the primary component of most comets we know. They also detected carbon dioxide and carbon monoxide, other common ices found in these primordial bodies. The chemical profile was at first looking familiar. Then they saw it. A clear, unambiguous spike in the data at the precise wavelength corresponding to methane gas, CH4, a simple molecule of one carbon atom bonded to 4 hydrogen atoms. On Earth, It is the primary component of natural gas. In the outer solar system, it is a common ice, forming the hazy atmospheres of Titan and the surfaces of Pluto. Finding methane in a comet was not in itself a shock. What was deeply, profoundly puzzling was the context. To understand the strangeness of this discovery, we must consider the nature of cometary activity. A comet is essentially a frozen object that becomes active when it's warmed by the sun. Imagine you have several different kinds of ice in a freezer: water ice, dry ice, frozen carbon dioxide, and frozen liquid nitrogen. Now, imagine you take them out and place them on a table. The liquid nitrogen, with a boiling point of -196 Celsius, would instantly flash into gas. It is hypervolatile. The dry ice, which sublimates at -78 Celsius, would begin to hiss and produce a thick fog. The water ice, stable until 0 Celsius, would remain solid for much longer. The ices on a comet behave in the same way, each with its own activation temperature determined by the sun's heat. At the time of the Webb observations, 3I/Atlas was incredibly far from the sun. It was still out in the frigid domain of the outer planets, roughly at the distance of Saturn's orbit. At this vast range, the sunlight is feeble, a pale imitation of the life-giving warmth we feel on Earth. The surface temperature of the comet was estimated to be extremely low. It was warm enough for some of the most volatile ices, like carbon monoxide, to begin turning into gas. But it should have been far, far too cold to sublimate methane ice in any significant quantity. Methane is more volatile than water ice, but much less volatile than carbon monoxide. For it to be streaming off the comet in the amounts Webb was detecting, the comet's surface needed to be substantially warmer than it was. It was as if someone had found a puddle of water forming around an ice cube in a deep freezer, set to -50 degrees. It simply didn't make physical sense. This was the core of the puzzle. The comet was actively outgassing a substance that, by all known laws of physics and chemistry, should have remained completely frozen solid at that distance. The implications were immediate and profound. Either our understanding of methane ice sublimation was flawed, or something very strange was happening on this alien visitor. Something was providing an extra source of energy, or the methane itself was stored in a completely unexpected way. The science teams were confronted with an anomaly, a result that defied easy explanation. And in science, it is precisely these anomalies, these moments of "that's funny," that often lead to the greatest breakthroughs. The race was on to formulate hypotheses, to imagine physical mechanisms that could explain the bizarre behaviour of this colossal methane-leaking messenger. The first line of inquiry focused on the nature of the ice itself. Perhaps the methane on 3I/Atlas was not stored as a simple, pure frost on the surface. In the ultra-cold, high-vacuum conditions of interstellar space and the primordial nebulae where comets form, ices don't always behave as they do in an Earth-based laboratory. One compelling theory is that the methane was not alone. It may have been trapped within a far more volatile type of ice, specifically an amorphous ice matrix dominated by carbon monoxide. Imagine a crystalline structure, like a perfectly built brick wall. Now imagine just dumping a pile of bricks randomly. That is amorphous ice. It's a disordered, high-energy state. Within this chaotic jumble of frozen carbon monoxide molecules, individual methane molecules could be physically trapped, like insects in amber. Carbon monoxide, being exceptionally volatile, begins to sublimate at very great distances from the sun, at extremely low temperatures. As the carbon monoxide matrix turned to gas, it would explosively release the methane molecules that were trapped inside. In this scenario, the methane outgassing is not driven by its own temperature, but is instead a secondary effect, piggybacking on the sublimation of a much more sensitive substance. It's like a package deal. As one ice goes, it takes the other with it. This co-sublimation model is elegant and fits many of the facts. It would explain why the methane was active so far from the sun. It also paints a vivid picture of the alien environment in which 3I/Atlas must have formed. For such a process to be dominant, the comet must have been born in a region of its home nebula that was incredibly cold and exceptionally rich in carbon monoxide. This provides a crucial chemical clue about the makeup of its parent solar system, suggesting a formation environment quite different from the one that birthed our own comets. A second, equally intriguing possibility delves beneath the comet's surface. The surface of a comet is a harsh place. Over billions of years drifting through the interstellar medium, it is bombarded by cosmic rays and micrometeoroids. This relentless radiation and impact processing can alter the surface chemistry, potentially depleting the most volatile ices. But deep within the nucleus, shielded by kilometers of overlying material, the primordial ices could remain perfectly preserved, untouched since the moment of their formation. Perhaps the methane Webb detected was not from a uniform surface layer, but from a singular, powerful outburst from one of these deep, pristine pockets. It could have been triggered by a small, recent impact that punctured the crust, or by internal stresses causing a fissure to open, venting a plume of ancient pressurized gas into space. Think of it like a cosmic geyser. The surface remains cold and largely inert, but a conduit opens to a warm, high-pressure reservoir deep below, producing a spectacular localized eruption. If this were the case, it would mean that we were incredibly lucky. We happened to be watching at the precise moment this interstellar object decided to reveal a sample of its deepest, most primordial interior. This hypothesis is tantalizing because it suggests that the true bulk composition of 3I/Atlas could be even more methane-rich than the surface appears. The outgassing we observed might be just a tiny hint of the vast reserves of hydrocarbons locked away in its colossal core. And this leads to the grandest speculation of all. What does this perplexing methane signature, combined with the comet's immense size, tell us about the place it calls home? This object is a physical sample, a messenger carrying direct information about the chemical and physical conditions of another protoplanetary disk. The abundance of methane and carbon monoxide, the sheer scale of the nucleus, all point to a birthplace that was perhaps colder or chemically different than the outer regions of our own early solar system. It offers us the first brushstrokes in a portrait of an alien stellar nursery. Perhaps its parent star was a different type than our Sun. Perhaps the region of the disk where 3I/Atlas formed was shielded from the star's radiation, allowing these volatile ices to condense and accumulate more efficiently. We are engaging in a new field, cometary archaeology on an interstellar scale. By sifting through the chemical debris of this visitor, we are learning about the construction materials available for building planets around another star. Methane is a carbon-bearing molecule. Carbon is the backbone of life as we know it. Seeing how this fundamental building block is distributed and transported across the galaxy provides a vital clue in the ongoing search for the origins of life. The water in Earth's oceans, the organic molecules that formed the first cells, many scientists believe they were delivered to the young Earth by a relentless bombardment of comets and asteroids. 3I/Atlas shows us that the galaxy is actively shuffling the deck. It is transporting these vital, life-enabling ingredients from one star system to another. The building blocks of worlds, and perhaps of life itself, are not confined to their home systems. They are galactic seeds, drifting on the void, waiting for a welcoming shore. The journey of 3I/Atlas through our solar system is a fleeting one. It made its closest approach, and is now heading back out into the great silent darkness from which it came. It will never return. Its brief passage has left us with more questions than answers, a beautiful and frustrating hallmark of all great scientific discoveries. We have a portrait of a colossal nucleus, a chemical spectrum filled with a puzzling methane signal, and a handful of compelling yet unproven theories. The data from Hubble and Webb will be analysed for years to come, as scientists build more sophisticated models to try and replicate the strange behaviour of this alien emissary. But the true significance of 3I/Atlas is not just in the data it provided, but in the promise of what is yet to come. We now know that interstellar space is not empty. It is populated by these wandering worldlets, and our ability to detect them is growing exponentially. Upcoming observatories, like the Vera Rubin Observatory in Chile, are predicted to find not just one or two of these objects, but dozens, perhaps hundreds. We are standing at the dawn of a new era of exploration, one where we don't have to send probes to other stars to sample their chemistry. The stars, through a cosmic delivery service, are sending samples to us. Each new interstellar visitor will be another piece of the puzzle, another clue from a different corner of the galaxy. Some may be rocky, like Oumuamua. Others may be rich in water or nitrogen or complex organic molecules. Each one will tell a unique story about its origin, allowing us to build a galactic library of planetary ingredients. By comparing these interstellar comets to our own, we can finally begin to understand what is common, what is rare, and what might be truly unique about our own solar system. This silent, ghostly traveller known as 3I/Atlas has reminded us that the universe is a place of profound mystery and endless surprise. It has shown us that even in the coldest, darkest voids, there is activity, chemistry, and a story waiting to be told. It is a story written in the language of molecules, broadcast on the frequency of infrared light, and captured by the insatiable curiosity of a species that has, for all its history, looked up at the night sky and wondered, what else is out there? The journey of this one comet is ending, but for us the exploration has just begun. The ghosts between the stars have started to speak, and we, at last, are learning how to listen. Undefined. The solar system is a vast, echoing cathedral of vacuum and light, yet its architecture is dictated by a single, overwhelming presence that resides 5 units of astronomical distance from the Sun. Here, the gas giant Jupiter sits upon a throne of gravity so profound that it bends the very fabric of the local void. It is not merely a planet, it is a celestial body of such immense proportions that it holds 2.5 times the mass of all other planetary bodies combined. If the rest of the solar system were placed on a cosmic scale, they would be outweighed by this single swirling sphere of hydrogen and helium. It is the undisputed monarch of the dark, a world that has remained in a state of arrested development since the dawn of the Sun's reign. For 4.6 billion years, Jupiter has drifted in the cold reaches of space, a silent sentinel that has watched the inner rocky worlds form, melt, and cool. It is a king without a crown, a star that never found its fire. In the primordial days of the solar nebula, Jupiter gathered the lion's share of the leftover gas and dust, growing with a hunger that threatened to rival the Sun itself. Yet, it stopped just short of the threshold. It attained the size and the stature of a giant, but it lacked the final necessary spark to ignite the nuclear furnace at its heart. Thus, it remains a failed sun, a massive archive of the early solar system's ingredients, locked away under layers of clouds that stretch for thousands of kilometers into the abyss. The outer visage of this giant is a tapestry of violent beauty. Bands of white, ochre, and deep crimson wrap around the planet like silken ribbons, driven by winds that scream at speeds of hundreds of kilometers per hour. These are not clouds of water vapor as seen on Earth, but frozen crystals of ammonia and ammonium hydrosulfide, swirling in a chaotic dance of fluid dynamics. Within these layers, storms the size of entire continents rise and fall, while the Great Red Spot, a cyclonic vortex twice the width of the Earth, has ground its way through the atmosphere for at least 300 years. This storm is a testament to the planet's internal energy, a crimson eye that stares out into the void, indifferent to the passage of eons. Descending through these top-level clouds, the environment shifts from the merely hostile to the physically impossible. The pressure mounts with every kilometre, crushing the gas into a hot, dense fluid. There is no solid surface to speak of. Instead, the atmosphere simply becomes thicker and more viscous until the distinction between gas and liquid vanishes entirely. Deep within this planetary shroud, the hydrogen is pressed so tightly that the very electrons are stripped from their protons. In this realm of absolute extremity, the hydrogen becomes a liquid metal, a substance that exists nowhere else in the solar system except in the Sun's own heart. This metallic hydrogen ocean creates a dynamo of electric currents, generating a magnetic field so vast that it reaches out to the orbit of Saturn, a shimmering shield of radiation that protects the Jovian moons while simultaneously bathing them in a lethal glow. At the very centre of this titan lies a core of rock and ice, perhaps 10 or 20 times the mass of the Earth, yet compressed into a sphere of unimaginable density. Here, the temperature rivals the surface of the Sun, reaching 24,000 degrees Celsius. This is the heart of the King, a place where the weight of an entire world presses down with the force of tens of millions of Earth atmospheres. It is a tomb of primordial matter held in a state of permanent stasis by the equilibrium of gravity and heat. Jupiter is a world of potential energy, a reservoir of hydrogen that has waited for billions of years for a catalyst that never came. The majesty of Jupiter lies in this very stillness. It is the guardian of the inner system, its massive gravity acting as a cosmic vacuum cleaner that sweeps up stray comets and asteroids, shielding the smaller, fragile worlds from the bombardment of the deep. It is the architect of orbits, the shepherd of the asteroid belt, and the reason for the current configuration of the planets. Without the heavy hand of the Jovian throne, the solar system would be a different, perhaps more chaotic place. Yet, for all its power, Jupiter remains a prisoner of its own physics. It is a giant that cannot grow, a fire that cannot burn, and a god that cannot wake. The stage is set across this vast, cold theatre. The Jovian system, with its 4 large Galilean moons and its dozens of smaller satellites, forms a miniature solar system unto itself. It is a masterpiece of celestial mechanics, a balanced equation that has persisted for nearly 5 billion years. But the architecture of the cosmos is not immutable. The laws that keep the gas giant in its state of arrested development are firm, yet they are subject to the variables of mass and pressure. If those variables were to be altered, if the king were finally given his crown of fire, the resulting transformation would ripple through every corner of the local universe. The silent majesty of the outer clouds and the immense pressures of the metallic interior are the tinder and the hearth, waiting for a spark that would challenge the very foundations of the local universe. Out of the cold, silent depths of the interplanetary void, a new shape emerges, a splinter of artificial intent cutting through the ancient radiation of the Jovian system. This is the 3-Eye Atlas, a probe that represents the pinnacle of human audacity and the ultimate extension of the species' desire to touch the untouchable. It does not resemble the clunky metallic boxes of the early space age. Instead, it is a sleek obsidian needle, a spearhead of dark matter and exotic alloys designed to do what gravity alone could not achieve. It is a messenger from a civilization that has grown tired of merely observing the giants and has decided instead to wake them. The craft approaches the gas giant with a cold, calculated precision, its trajectory aimed directly at the heart of the Great Red Spot. As it crosses the threshold of the outer atmosphere, the probe is immediately engulfed in the swirling chaos of the upper troposphere. Around it, the winds howl at speeds that would level cities on a terrestrial world, yet the 3-Eye Atlas remains indifferent to the buffeting of ammonia clouds and the crackle of super bolts of lightning that stretch for hundreds of kilometers across the sky. It descends like a scalpel, slicing through the layers of ochre and crimson, piercing the very eye of the storm that has defined the face of Jupiter for centuries. At the heart of this probe lies a core that defies the conventional laws of chemistry and physics. It is a grain of concentrated dark matter, a substance that interacts with the visible universe only through the relentless pull of gravity. For eons, the gas giant has existed in a state of hydrostatic equilibrium, a delicate billions of years old standoff between the inward pull of its own mass and the outward pressure of its internal heat. This balance is what has kept Jupiter a planet, preventing it from collapsing further and igniting the nuclear fire of a star. The 3-Eye Atlas is designed to shatter this equilibrium. By carrying a payload of dark matter, the probe introduces a localized gravitational well of such intensity that it mimics the presence of a much more massive body. As the probe sinks deeper into the crushing depths of the metallic hydrogen ocean, the dark matter core is activated. It does not explode, it simply begins to pull. The surrounding hydrogen, already squeezed into a liquid metallic state by the weight of the planet above, finds itself subjected to a new impossible force. The probe creates a pocket of space where the density of matter is forced to escalate beyond the natural limits of the planet's mass. It is a gravitational needle, stitching the fabric of space-time tighter and tighter, drawing the hydrogen nuclei into a proximity that the universe had previously forbidden for a body of this size. The physics of this intervention are a direct challenge to the architecture of the local cosmos. In a natural setting, a planet requires approximately 13 times the mass of Jupiter to even begin the most basic form of nuclear fusion. Jupiter, for all its majesty, is a lightweight in the stellar arena. But the 3I Atlas bypasses this requirement through the sheer, concentrated influence of its dark matter core. It creates a localized zone of hyperdensity, a small volume of space where the pressure exceeds the threshold of the Sun's own interior. Within this zone, the hydrogen atoms are no longer able to maintain their distance. The electromagnetic repulsion that usually keeps them apart, the Coulomb barrier, begins to buckle under the artificial weight of the probe's gravitational well. The descent continues into the dark, hot heart of the giant. The probe is now a ghost in the machine, a tiny point of absolute gravity that is dragging the planet's substance along with it. The metallic hydrogen through which it passes is no longer a passive fluid. It is being compressed into a state of unnatural density, a precursor to the birth of something new. This is the ultimate expression of human curiosity, a what-if rendered in dark matter and steel. The 3I Atlas is not just a scientific instrument, it is a catalyst for a planetary metamorphosis. It is the finger on the trigger of a cosmic gun, aimed at the heart of the king. As the probe reaches the designated depth, the localized gravitational well reaches its peak intensity. The surrounding environment is now a crucible of white-hot pressure, a place where the distinction between a planet and a star begins to blur. The 3I Atlas has successfully bypassed the laws of hydrostatic equilibrium, creating a bubble of stellar conditions within a planetary body. The hydrogen nuclei are now so close that they are on the verge of touching, their individual identities beginning to merge into the collective energy of a nascent sun. The silence of the deep Jovian interior is about to be shattered by the first heartbeat of a new star, an artificial ignition that will rewrite the rules of the solar system. The king is about to receive his crown, but it is a crown of fire that may consume everything he once ruled. The activation of the 3I Atlas is not a loud event. In the crushing silence of the deep interior, it begins as a tremor in the geometry of space itself. Within the heart of the metallic hydrogen ocean, the dark matter core reaches its peak gravitational pull. The first pair of protons, forced into an impossible embrace, overcome their mutual repulsion and fuse. In that microsecond, a single helium nucleus is born, and with it, a burst of gamma radiation that marks the end of Jupiter's life as a mere planet. This is the first spark of the nuclear fire, a tiny, invisible pinprick of light that carries the weight of 1,000 suns. The energy released by these initial fusions does not remain contained. It begins to radiate outward, a silent ripple of heat that encounters the dense, conductive layers of liquid metal. The metallic hydrogen, which has acted as a passive reservoir for billions of years, now becomes a medium for the most energetic reaction in the known universe. A shockwave of thermal pressure expands from the probe's location, pushing back against the weight of the planet. For a brief moment, the hydrostatic equilibrium of the giant is thrown into chaos. The interior of the planet, once a cold and dark abyss, is suddenly illuminated by the birth of a million-degree furnace. Far above, on the visible surface of the planet, the transformation manifests as a terrifying change in the Great Red Spot. This ancient vortex, which has spun for centuries as a cyclone of ammonia and methane, begins to glow. The deep crimson of the storm, caused by the complex organic molecules dredged up from the depths, is bleached away by a rising tide of pure white light. The centre of the spot begins to boil, not with wind, but with the upwelling of stellar plasma. The Great Red Spot is no longer a storm, it has become a chimney, a primary furnace for the nascent star that is waking beneath the clouds. The eye of the giant, once red and brooding, turns into a blinding white aperture that screams light into the void. As the ignition stabilizes, the atmosphere of Jupiter undergoes a violent metamorphosis. The bands of clouds that have defined the planet's appearance are torn asunder by the rising heat. The ammonia ice crystals melt and vaporize, replaced by the ionized glow of a hydrogen-helium plasma. The entire hemisphere centered on the Great Red Spot begins to bulge, the internal pressure of the nuclear reaction fighting to expand the planet's volume. The light that pours out of the white eye is not the soft reflected glow of the sun. It is the harsh, unfiltered radiation of a red dwarf. It is a light that carries the signature of the proton-proton chain, a spectrum of energy that has not been seen in this part of the solar system since the sun was a mere protostar. The surrounding moons are the first to witness the arrival of the second sun. Io, the closest of the Galilean satellites, is bathed in a brilliance that dwarfs the distant sun. Its volcanic plains, already tortured by Jovian tides, are now seared by an intense ultraviolet glare. The sulphurous frosts that coat its surface begin to sublimate instantly, creating a temporary glowing atmosphere of yellow haze. Europa, the ice-crusted world of hidden oceans, sees its frozen plains illuminated with a terrifying clarity. The cracks in its icy shell, known as lineae, glow like neon veins as the new light penetrates the translucent surface. The moons are no longer orbiting a dark protector. They are now trapped in the inner sanctum of a volatile newborn star. Ganymede and Callisto, further out in the Jovian suburbs, see their long nights extinguished. The shadows cast by their craters are suddenly erased by the white-hot glare of their parent. The light from the ignited Jupiter is so intense that it casts sharp shadows on the moon's surfaces, shadows that move with a speed that reflects the planet's rapid rotation. This is a light they were never meant to see, a radiation that begins to strip away the delicate layers of water ice and frozen gases that have accumulated over billions of years. The Jovian system has been transformed into a crucible, a laboratory of fire where the old rules of planetary science no longer apply. The ignition is now self-sustaining. The 3i Atlas has done its work, creating a bridge between the planetary and the stellar. The hydrogen nuclei continue to fuse, releasing a steady stream of energy that keeps the core at a temperature of millions of degrees. The planet is expanding, its outer layers swelling as the heat from the core pushes outward. Jupiter is no longer a king without a crown. It has become a beacon, a second source of light and heat in a system that has known only one for 4.6 billion years. The architecture of the local cosmos has been irrevocably challenged, and the consequences of this artificial dawn are only just beginning to unfold. The white eye of the Great Red Spot remains fixed on the heavens, a witness to the birth of a god and the potential death of a world. In the quiet halls of intellectual history, the year 1939 marks a turning point in the human understanding of the heavens. It was then that Hans Bethe first charted the invisible furnace of the stars, unravelling the complex sequences of nuclear reactions that allow a sun to hold back the darkness. He looked into the heart of the sun and saw not just fire, but a subatomic struggle of monumental proportions. This legacy of stellar nucleosynthesis, once a mere theoretical framework scrawled on chalkboards, now finds its physical manifestation in the heart of Jupiter, driven by the relentless influence of the 3i Atlas. The probe acts as a catalyst for the very process Bethe described, forcing the universe to perform its most sacred alchemy in a place where it was never meant to occur. The primary obstacle to the birth of any star is the Coulomb barrier, an invisible wall of electromagnetic repulsion that keeps protons from ever touching one another. Because every hydrogen nucleus carries a positive charge, they repel each other with a ferocity that increases as they are pushed closer together. In the natural state of Jupiter, even at its crushing core, the temperature and pressure are insufficient to overcome this defiance. The protons dance around one another, forever separated by the fundamental laws of electricity. However, the 3i Atlas introduces a variable that the natural world cannot provide. Its dark matter core creates a localized gravitational well, so steep and so deep that the Coulomb barrier is no longer an absolute defence. Under this artificial weight, the hydrogen nuclei are herded together like panicked animals, their mutual repulsion slowly being crushed by the sheer, unyielding force of the probe's gravity. The subatomic struggle begins as a slow, agonising approach. Two protons are forced into a proximity that defies their nature. They scream away from each other with electromagnetic hate, yet the dark matter needle continues to tighten the noose of space-time. Suddenly, the distance between them drops to a point where the weak nuclear force can intervene. In a flash of quantum transformation, one of the protons sheds its positive charge, emitting a positron and a ghost-like neutrino, and transforms into a neutron. The two particles, once enemies, are now bound together as a nucleus of deuterium, or heavy hydrogen. This is the first link in the proton-proton chain, the fundamental heartbeat of the stellar engine. The energy released in this single transformation is minuscule, but when repeated trillions of times per second, it becomes a tide of power that can hold up the weight of a world. The chain continues with relentless efficiency. The newly formed deuterium nucleus is almost immediately struck by another wandering proton, forced into the collision by the probe's relentless pressure. They fuse instantly, creating a nucleus of helium-3 and releasing a high-energy gamma ray, a shriek of light that begins its long, tortuous journey out of the dense Jovian interior. The final act of this subatomic drama occurs when two of these helium-3 nuclei collide. They merge into a stable nucleus of helium-4, the ash of the nuclear furnace, and in doing so, they eject two surplus protons back into the fray to start the cycle anew. In this process, a small fraction of the original mass is lost, converted directly into pure energy according to the ancient mathematics where energy equals mass times the speed of light squared. This is the birth of the M-type red dwarf, the smallest and most enduring class of star in the cosmos. By forcing these reactions to occur, the 3I Atlas has transformed Jupiter from a passive reservoir of gas into an active participant in the galaxy's energy cycle. The energy produced by the proton-proton chain creates an outward thermal pressure that finally rivals the inward pull of gravity. The interior of the planet, once a cold sea of metallic hydrogen, is now a roiling plasma of ionized gas, white-hot and screaming with the movement of newly forged helium. Each helium nucleus is a tiny monument to the human will, a piece of matter that did not exist seconds before, forged in the artificial crucible of the probe's making. The resulting star is a dim crimson thing compared to the Sun, yet it is a star nonetheless. It is an M-type dwarf, a stellar body characterized by its low mass and its incredible longevity. In the natural order, such stars can burn for trillions of years, sipping their hydrogen fuel with a parsimony that puts larger stars to shame. But here, the birth is forced, and the conditions are volatile. The star is born into a planetary body that was never designed to house such a furnace. The energy from the proton-proton chain begins to saturate the metallic hydrogen layers, turning the entire planet into a heat engine of unprecedented scale. The legacy of 1939 has been brought to life in the most violent way possible, and the subatomic struggle at the core is now a macroscopic threat to the stability of the entire Jovian system. The fire has been lit, the helium is accumulating, and the king of planets has finally, painfully, become a sun. Since the winter of 1610, when Galileo Galilei first turned his primitive glass lenses toward the heavens and discovered the 4 Medicean stars orbiting the gas giant, humanity has recognized Jupiter as a system of its own. Those 4 points of light, Io, Europa, Ganymede and Callisto, revealed that the cosmos did not revolve around the Earth, but rather followed the dictates of mass and gravity. Yet, for all the centuries of observation that followed, a fundamental boundary remained uncrossed. Jupiter, despite its status as the most massive object in the solar system after the Sun, existed in a state of celestial frustration. It was caught below the brown dwarf threshold, a mathematical and physical line in the sand that separates the planets from the stars. To understand the magnitude of the transformation wrought by the Three-Eye Atlas, one must first understand the cold reality of this threshold. In the natural order of the universe, a gas giant must possess approximately 13 times its current mass to ignite even the most basic form of nuclear reaction, the fusion of deuterium. Deuterium, an isotope of hydrogen with a single neutron, is the low-hanging fruit of the nuclear world. It requires less pressure and lower temperatures than the primary proton-proton chain to fuse. However, Jupiter is a lightweight in this cosmic arena. It is a giant among planets, but a runt among stars, possessing only a fraction of the mass required to generate the million-degree temperatures at its core necessary to spark that first deuterium flame. It is a world of cold, high-pressure chemistry, forever denied the dignity of stellar ignition by the simple lack of bulk. The brown dwarf threshold is not merely a number, it is a physical reality defined by the struggle between gravity and the quantum nature of matter. In bodies smaller than 13 Jupiter masses, the internal pressure is provided by electron degeneracy, a quantum mechanical effect where electrons refuse to be squeezed into the same space. This pressure is sufficient to hold up the weight of a planet like Jupiter, but it also keeps the core too cool for fusion. To become a star, or even a brown dwarf, a body must have enough gravity to overcome this quantum resistance and crush the core into the regime of nuclear fire. Jupiter has spent 4.6 billion years in this subcritical state, a massive ball of gas that never quite made the grade. The Three-Eye Atlas effectively rewrites this 4 billion year history in a matter of seconds. By introducing a concentrated well of dark matter into the planet's heart, the probe creates an artificial gravitational environment that mimics the presence of those missing 12 Jupiter masses. It is a sleight of hand performed against the laws of nature. The dark matter does not add physical matter in the form of hydrogen or helium. Instead, it provides the pure, unadulterated pull of gravity. It tricks the surrounding metallic hydrogen into believing it is at the centre of a much larger, much more massive body. The gap between a failed star and a living sun is bridged not by the slow accumulation of cosmic dust, but by the focused application of exotic physics. This state, however, is one of extreme fragility, a sharp contrast to the serene and ancient stability of the Sun. The Sun is a self-regulating masterpiece of hydrostatic equilibrium. If its core gets too hot, it expands, which lowers the density and slows the fusion rate. If it cools, it contracts, increasing the pressure and speeding the fusion back up. This beautiful negative feedback loop has allowed the Sun to shine with a steady, life-giving light for billions of years. It is a massive, self-correcting engine of hydrogen. The newly ignited Jupiter, by comparison, is a volatile and forced entity. Its ignition is not the result of its own inherent nature, but of an external catalyst that must be perfectly maintained. The new Jovian Sun exists in a state of permanent tension. The outward pressure of the new nuclear fire is fighting against a gravitational pull that is essentially artificial. Unlike the Sun, which has the vast inertia of its own enormous mass to buffer any changes, the ignited Jupiter is a planetary body being pushed far beyond its structural limits. The metallic hydrogen layers, once stable, are now roiling with a heat they were never meant to contain. The entire planet is a pressurized vessel on the verge of structural failure. It is a star held together by a needle of dark matter, a flickering candle in a cosmic storm. This forced, volatile existence means that the new Jovian Sun lacks the graceful longevity of a natural red dwarf. While a natural star of this mass might burn for trillions of years in a slow, steady simmer, the artificial ignition of Jupiter is a violent, high-stakes experiment. The very presence of the Three-Eye Atlas creates a localized point of extremity that the rest of the planet must struggle to accommodate. The balance is precarious. The slightest fluctuation in the dark matter core or a shift in the convective layers of the planet could lead to a catastrophic collapse of the fusion reaction or a runaway explosion of the outer atmosphere. The king has been given his crown, but it is a crown of glass, held together by the sheer will of human technology, standing in stark, trembling contrast to the ancient, golden stability of the sun that has watched over this system since the beginning of time. The Grand TAC model, a cornerstone of planetary science refined in the year 2011, tells the story of a young Jupiter that once migrated toward the Sun before being pulled back by the emergence of Saturn. This ancient migration cleared the path for the inner planets and dictated the sparse, scattered nature of the asteroid belt, acting as a sculptor that shaped the very foundations of the worlds we inhabit. Today, that delicate 4 billion-year-old balance is being dismantled by the artificial hand of the 3I Atlas. As the probe's dark matter core intensifies the effective mass of the gas giant, the gravitational yoke that Jupiter holds over the solar system tightens with terrifying speed. The invisible hands of gravity, once a steady and predictable grip, now reach out like the fingers of a hungry god, clawing at the orbits of the primordial debris that has sat undisturbed for millions of millennia. Between the orbits of Mars and the newly ignited Jovian sun lies the asteroid belt, a graveyard of failed worlds and frozen remnants from the dawn of the system. For eons, these rocks have followed stable paths, held in check by the subtle resonance of Jupiter's natural mass. But as the planet's density increases, these resonances are shattered. The Kirkwood gaps, those empty lanes in the belt cleared by Jupiter's gravity through periodic tugs, begin to shift and widen, swallowing the asteroids that once skirted their edges. The orbital energy of these rocks is stolen or amplified in an instant. Huge masses of nickel, iron and silicate, some the size of mountains and others the size of small moons, are plucked from their ancient cycles as if they were nothing more than dust in a gale. The first to feel the touch of this new gravity are the largest residents of the belt. Ceres, a dwarf planet and the queen of this rocky realm, finds its path nudged by a force it cannot resist. Its nearly circular orbit begins to elongate, stretching into a dangerous ellipse that will eventually bring it into the path of the inner planets. Vesta, a jagged world of basaltic rock, is similarly disturbed, its ancient crust trembling as the tidal forces of the distant, heavier Jupiter pull at its core. These are the planet killers, the silent voyagers of the dark that carry the kinetic energy of 1 billion nuclear bombs. Under the influence of the heightened Jovian pull, their trajectories are no longer circular or predictable. They are flung inward, redirected by a gravitational slingshot that sends them screaming toward the sun. The inner solar system, once a relatively peaceful expanse of vacuum, is transformed into a chaotic shooting gallery. The orbits of Mars, Earth and Venus are now intersected by thousands of new, high-velocity intruders. Each rock is a jagged spear of primordial matter, accelerated to tens of thousands of kilometers per hour. As they fall toward the sun, they trail thin veils of dust, illuminated by the dual light of the sun and the newborn Jovian star. This dust creates a thick, glowing haze in the ecliptic plane, a zodiacal light of unprecedented brightness that signals the onset of a new era of bombardment. The vacuum is no longer empty, it is crowded with the shrapnel of a broken belt. The mechanics of this disruption are relentless and indifferent. Gravity is a long-range force, and the increase in Jupiter's effective mass is felt across hundreds of millions of kilometers. It is a slow-motion catastrophe where the mathematics of celestial mechanics dictate the doom of distant worlds. The asteroids do not fall all at once. They tumble and collide, breaking into smaller, equally lethal fragments that fill the space between worlds with a haze of lethal debris. The stable clockwork that has governed the movement of the planet since the era of the Great Bombardment, the last time the system saw such violence, is being wound until the spring snap. The very architecture of the solar system is being unmade as the King of Planets asserts a new, more tyrannical authority over the debris of his kingdom. This is the price of the artificial sun. The light that now bathes the Jovian moons is paid for by the destabilization of the entire inner system. The Grand TAC was a dance of creation that allowed the Earth to form in a protected pocket of space, free from the constant threat of extinction-level impacts. The current transformation is a dance of destruction, a reversal of that ancient order. As the first of the displaced asteroids cross the orbit of Mars, the rocky worlds are forced to face a reality they have not known for billions of years. The sky is no longer a safe canopy of distant stars, it is a crowded theatre of incoming fire. The invisible hands of the new Jovian sun are throwing the very bones of the solar system at the feet of the inner worlds, and the grace period of the last 66 million years is coming to a violent, fiery end. The solar system has functioned for 4.6 billion years as a masterpiece of precision, a clockwork of concentric circles where every gear and lever is made of gravity. But the increase in Jupiter's mass, forced by the three-eye atlas, acts as a heavy weight dropped onto a delicate balance scale. The first to feel this dislocation is Mars. The red planet, already a world of thin air and frozen deserts, sits nearest to the Jovian giant. Its orbit, which has remained a stable, slightly elongated circle for millions of years, begins to warp. The invisible tether between the Sun and Mars is being stretched by the rival pull of the new Jovian Sun. Mars is being dragged outward during its closest approach to Jupiter, its path becoming a more extreme ellipse. This is not a sudden leap, but a rhythmic, relentless tug that steals orbital momentum, threatening to eventually pull the red planet into a realm where the Sun's warmth is a distant memory. Even the Earth, nestled in the protective embrace of the habitable zone, is not immune to this gravitational heresy. The blue world is a captive of its own momentum, yet that momentum is now being subtly redirected. The Milankovitch cycles, the slow rhythmic changes in the Earth's orbit and tilt that have dictated the ebb and flow of ice ages for eons, are being overridden by a much more powerful and immediate force. The perihelion, the point where the Earth is closest to the Sun, begins to shift. The length of the tropical year, the foundation of every human calendar, fluctuates as the Earth is alternately accelerated and slowed by the shifting barycenter of the solar system. The Sun itself is no longer the sole anchor of the planetary dance. It is being pulled into a more violent wobble by the increased mass of its largest child. As the Earth's orbit stretches, the seasons begin to lose their ancient predictability. The winters grow longer and more severe as the planet lingers further from the Sun, while the summers become short, intense bursts of heat as the Earth swings closer to the solar furnace to compensate for its stolen energy. The delicate atmospheric balance that has allowed life to flourish is predicated on a stable distance from the Sun. Now, that distance is a variable, a number that changes with every Jovian year. The oceans, the great thermal regulators of the world, struggle to keep pace with the shifting solar input. Currents that have flowed for thousands of years, such as the Atlantic meridional overturning circulation, begin to falter as the planetary temperature gradients are rewritten by the new orbital geometry. Deeper in the well, Venus and Mercury feel the tremor of the Jovian awakening. Even though they are shielded by the overwhelming gravity of the Sun, the shift in the solar system's centre of mass causes their orbits to precess at an accelerated rate. The entire system is like a spiderweb where one of the main anchors has been pulled too tight. Every strand vibrates with the tension. The long-term stability of the solar neighbourhood is no longer a given. In the cold mathematics of celestial mechanics, even a change of 1% in the mass of a major planet can lead to the eventual ejection of another, or a catastrophic collision over the course of several million years. The clockwork is breaking. The gears are grinding against one another, and the silent, smooth motion that has characterized the last few billion years is being replaced by a jerky, unstable progression toward an uncertain future. The solar system is losing its balance. The Goldilocks stability that allowed a collection of atoms to organize themselves into sentient life was a gift of the specific masses and distances that have existed since the beginning. By altering the king of planets, the three-eye atlas has introduced a fundamental instability into the home of humanity. The rocky worlds are no longer on fixed tracks. They are on a journey into the unknown, guided by the heavy, invisible hand of a newborn star that was never supposed to exist. The sky is shifting, the ground is moving, and the very rhythm of existence is being pulled out of alignment, by the gravitational hubris of a species that dared to rewrite the laws of the heavens. This orbital decay is a slow poison. Unlike the immediate violence of an asteroid impact, the perturbations of the planets take years to manifest as global crises, yet they are far more inescapable. There is no shield that can block the pull of gravity, no technology that can return a planet to its rightful groove once the balance has been tipped. The inner solar system is entering a period of chaotic transition, where the old maps of the heavens are becoming obsolete. The stars in the night sky may remain the same, but the path the Earth takes beneath them is being rewritten by the white-hot eye of the new Jovian sun, a reminder that in the mechanical theatre of the cosmos, every action has a reaction that can span the width of a solar system and the length of eternity. The magnetic shroud of Jupiter, once a silent guardian of its many moons, transforms into an instrument of absolute sterilization. Even before its ignition, the Jovian magnetosphere was the largest coherent structure in the solar system, a vast teardrop of invisible force reaching millions of kilometers into the dark. Now, with the birth of the red dwarf at its heart, this field is supercharged by a torrent of high-energy particles. The internal dynamo, fueled by the roiling metallic hydrogen and the new thermal energy of fusion, spins with a frantic, renewed vigor. The magnetic field lines do not merely hum, they scream as they accelerate electrons and protons to near-light speeds. The Van Allen belts, once dangerous zones of radiation, swell into a lethal Jovian wind that rivals the output of the sun itself. This is not a gentle breeze of ions, but a continuous high-velocity bombardment of radiation that scours everything in its path. Ganymede, the largest moon in the solar system, and the only one to possess its own internal magnetic field, is the first to suffer the consequences of this new reality. Its own magnetosphere, which once provided a modest shield against the Jovian environment, is instantly overwhelmed. The magnetic field lines of the new star snap and reconnect with those of the moon, creating open funnels that pour high-energy plasma directly onto the icy poles. The thin, delicate atmosphere of oxygen, a ghostly remnant of billions of years of ice splitting, is stripped away in a matter of hours. Without the weight of an atmosphere to hold it back, the surface ice begins to sublimate at a terrifying rate. The ultraviolet and X-ray emissions from the Jovian furnace strike the frozen plains with the force of a physical hammer. The ancient ice, which has survived since the formation of the system, cracks and boils. White plumes of water vapour erupt from the surface, only to be immediately ionized and swept away by the screaming solar wind. What was once a world of hidden oceans and potential biological secrets is transformed into a seared, irradiated husk of silicate rock and salt. Callisto, the outermost of the four great moons, was long considered the most stable and ancient surface in the Jovian neighbourhood. Its cratered face, a record of 4 billion years of cosmic impacts, is now subjected to a heat it was never meant to endure. The new red dwarf, though dim compared to the sun, is only a few million kilometers away. The radiation flux on the surface of Callisto increases by a factor of thousands. The carbon dioxide and nitrogen ices that have clung to the shadows of its deepest craters for eons vanish in a silent puff of gas. The dark, dusty material that covers the surface of the moon absorbs the intense ultraviolet light, heating the crust until the subsurface ice layers begin to groan and shift. The very ground of Callisto becomes a source of gas, a dying world exhaling its last remnants into the void. The radiation apocalypse does not leave behind a scorched desert, but a sterilized skeleton of a world, stripped of every volatile element that once made it a candidate for human exploration. The space between the moons, once a vacuum filled with the soft glow of reflected sunlight, is now a glowing soup of lethal plasma. The Jovian wind clashing with the solar wind creates a bow shock of such intensity that it can be detected from the outer reaches of the Kuiper belt. This radiation is not merely a threat to the moons, it is a barrier that cuts off the Jovian system from the rest of the solar system. Any craft attempting to approach the new star would be fried by the intense X-ray flux, long before it reached the outer orbits. The ignition has created a forbidden zone, a kingdom of light and death where the laws of biology are discarded in favour of the laws of high-energy physics. The moons, once the jewels of the Jovian crown, are now nothing more than targets in a cosmic shooting gallery, their potential for life extinguished by the very fire that was meant to crown their king. The transformation is total. The icy surfaces of the Galilean satellites, which once held the promise of vast subterranean oceans, are now the front lines of a stellar war. The heat from the red dwarf penetrates the crusts, causing the internal oceans to expand and the icy shells to fracture. Great geysers of steam and salt water spray into the vacuum, creating a shimmering ring of ice around the new star. This ring is not the majestic, orderly structure of Saturn, but a chaotic, glowing torus of ionized gas and frozen shards, a shroud for the dead worlds that once orbited a planet. The radiation apocalypse is a silent, invisible fire that leaves the Jovian system changed forever, a collection of barren, irradiated husks orbiting a sun that was born of human ambition and dark matter. The ancient stillness of the outer planets has been replaced by a violent, energetic environment, where the only constant is the relentless flow of lethal radiation. The light from the newly born Jovian star travels across the vast gulf of the outer solar system, crossing hundreds of millions of kilometers to reach the fragile blue marble of Earth. It arrives not as a second sun that rivals the primary, but as a persistent, unblinking eye that refuses to let the world sleep. This new celestial body possesses a luminosity approximately 1/1000th the brightness of the sun, a figure that sounds modest until it is compared to the familiar night sky. At this intensity, the ignited Jupiter shines hundreds of times brighter than the most brilliant full moon. It is a sharp, concentrated point of light, a violet-white needle that pierces the velvet curtain of the night, casting hard, distinct shadows across the landscape long after the sun has dipped below the horizon. With the arrival of this secondary light, the concept of true night is extinguished from the human experience. The deep obsidian blackness that once allowed the Milky Way to stretch its silver arms across the heavens is gone, replaced by a perpetual and eerie violet twilight. As the light from the M-type red dwarf filters through the Earth's nitrogen and oxygen atmosphere, it undergoes a unique scattering. The red-heavy spectrum of the Jovian sun, clashing with the natural blue scattering properties of the air, bathes the world in a bruised lavender hue. Even when the sun is on the opposite side of the planet, the sky remains a dim, glowing canopy. The stars of the distant galaxy, the ancient guides of navigators and poets, are drowned out by this local interloper. Only the brightest planets and the most brilliant first-magnitude stars can fight through the violet haze, leaving the human race isolated from the broader cosmos by a veil of its own making. The biological consequences of this eternal dusk are immediate and profound. Life on Earth has evolved over billions of years in response to a strict 24-hour cycle of light and absolute darkness. This rhythm is hard-coded into the very molecular machinery of every living organism, from the simplest bacteria to the most complex mammals. At the centre of this system is the production of melatonin, a hormone that signals the body to repair itself and rest, triggered by the absence of light. In the new era of the Jovian sun, the master clock of the suprachiasmatic nucleus is thrown into a state of permanent confusion. The pineal gland, waiting for a darkness that never comes, fails to release the necessary chemical signals for deep sleep. Across the globe, the human population enters a state of chronic sleep deprivation, a collective exhaustion that fraying the edges of sanity and social order. In the natural world, the disruption is even more catastrophic. Nocturnal predators, whose entire existence is predicated on the cover of darkness, find themselves exposed. The owl, the leopard, and the bat lose their evolutionary advantage as the violet twilight reveals their movements to their prey. Conversely, prey animals that rely on the shadows to hide are now visible at all hours, leading to a frantic, unsustainable shift in the predator-prey dynamic. Migratory birds, which use the stars and the subtle polarization of the night sky to navigate across continents, find their internal compasses spinning aimlessly. They collide with buildings or wander off course, their ancient journeys interrupted by a light that should not be there. The botanical world too begins to falter. Many plants rely on a process known as photoperiodism, using the length of the night to determine when to flower, when to drop their leaves, or when to enter dormancy. The constant presence of the Jovian light tricks these plants into a state of perpetual summer, or prevents them from recognizing the onset of winter. Forests become confused, with trees blooming out of season only to be killed by the inevitable frosts, while agricultural cycles that have fed humanity for millennia are rendered unpredictable. The very foundation of the food chain is shaken as the primary producers struggle to reconcile their internal chemical calendars with the violet glow of the sky. The psychological toll on humanity is a slow, burning crisis. The loss of the night is the loss of a fundamental human right, the right to look into the infinite and feel the perspective of the void. The constant light creates a sense of agitation, a feeling that the day never truly ends and that the world is always watching. In cities and rural villages alike, the eerie violet glow reflects off the surfaces of lakes and the glass of skyscrapers, a constant reminder of the hubris that led to the ignition of a planet. The world is bathed in a beauty that is both sublime and terrifying, a light that reveals everything but offers no comfort. The reign of two suns has turned the Earth into a laboratory of biological stress, where the ancient harmony of the spheres has been replaced by the relentless humming glare of a man-made god. The violet twilight is not a new dawn, but a lingering sunset for the natural order, a period of transition where the old ways of life are being burned away by the cold, distant fire of the Jovian throne. The cosmic order is governed by a set of uncompromising laws, and among the most absolute is the Eddington limit. This principle serves as the final arbiter in the life of any star, defining the precise point where the outward push of radiation pressure balances the inward pull of gravity. In a stable star like the Sun, these two forces exist in a state of graceful tension, a billions of years-long stalemate that prevents the star from either collapsing into a singularity or blowing itself apart. But in the artificial sun of Jupiter, this balance is a fragile lie maintained by the three-eye atlas. As the nuclear fire at the core intensifies, the photons generated by the proton-proton chain begin to exert a physical force on the surrounding layers of metallic hydrogen. This radiation pressure is a relentless, outward-driving wind that seeks to expand the planet, while the gravity of the dark matter core desperately tries to hold the substance together. The fundamental problem lies in the disparity between the probe's localized influence and the vast, diffuse bulk of the gas giant. While the three-eye atlas creates a point of extreme density at the center, it cannot rewrite the laws of physics for the entire volume of the planet. Jupiter is, by stellar standards, a bloated and low-density object. Its gravity, even when augmented by the dark matter needle, lacks the total mass to anchor the violent energy being produced in its depths. As the temperature of the core climbs into the millions of degrees, the outward pressure of the light begins to exceed the gravitational ceiling. The star reaches its Eddington limit, and the result is not stability, but a slow-motion disintegration. The outer layers of the planet, no longer pinned down by sufficient weight, begin to lift away from the core, swelling the planet to a size that defies its structural integrity. This expansion triggers a catastrophic breakdown of the star's internal circulation. In a healthy star, convection currents act as a planetary conveyor belt, bringing fresh hydrogen fuel down into the core and carrying heat away to the surface. However, the runaway radiation pressure in the ignited Jupiter disrupts these cycles. The heat becomes so intense that it pushes the hydrogen fuel away from the fusion zone, creating a vacuum of sorts around the dark matter core. The star begins to choke on its own energy. Without a steady supply of new nuclei to fuse, the nuclear reaction falters and the outward pressure momentarily drops. Gravity then seizes the opportunity to slam the outer layers back down toward the center, creating a violent compression that reignites the fire with a sudden, unstable burst of power. The result is a terrifying celestial flicker. From the perspective of the inner solar system, the new Jovian sun is no longer a steady violet-white point of light. It begins to stutter, its luminosity surging and dipping in a rhythmic, agonizing pulse. Each surge sends a fresh shockwave of radiation through the Jovian system, further scouring the already devastated moons. Each dip sees the planet contract with a groan of gravitational force that ripples through the fabric of space-time. The artificial star is gasping for breath, unable to find the equilibrium required for stellar life. It is a body caught in a terminal oscillation, a victim of the very laws that allow the rest of the universe to shine. The instability spreads outward through the planetary atmosphere. The once orderly bands of clouds are now a chaotic froth of plasma, being whipped into a frenzy by the internal pulsations. The great red spot, which had served as the primary chimney for the nuclear furnace, begins to tear itself apart. The white eye of the storm flickers and dims as the upwelling of plasma becomes irregular. The entire planet is vibrating, a gargantuan bell being struck by the hammer of nuclear fusion. It is the sound of a world that was never meant to be a star trying to shed the burden of its own light. The three-eye atlas, for all its technological sophistication, cannot provide the one thing the experiment needs most: the sheer, unadulterated mass of a true stellar parent. This is the beginning of the collapse. The realization dawns that the cosmos has very specific reasons for keeping its giants asleep. The Eddington limit is not just a mathematical threshold, it is a safety valve that prevents the universe from being filled with short-lived volatile monsters. The experiment with the three-eye atlas has reached the end of its theoretical leash. The artificial gravity of the dark matter core is being overwhelmed by the very fire it ignited. As the flickers become more erratic and the pulsations more violent, the structural failure of the Jovian sun becomes inevitable. The king is losing his crown, not to an outside enemy, but to the inherent limitations of his own throne. The fire is dying, not for a lack of fuel, but because the vessel containing it is shattering under the strain of its own ambition. The violet twilight on Earth begins to waver, a premonition of the darkness that is soon to return, as the gas giant prepares to surrender its stolen fire back to the cold indifference of the void. The universe operates as a vast and indifferent engine, a mechanism of entropy that grinds toward a heat death across trillions of years. In this cold, mathematical expanse, the brief ignition of a gas giant in an unremarkable corner of the Milky Way is a negligible flicker, a rounding error in the energy budget of a single galaxy. The cosmos does not possess a consciousness to judge the audacity of the three-eye atlas, nor does it have a heart to mourn the sterilization of the Galilean moons. It is a clockwork of physics, governed by the relentless laws of thermodynamics and gravity, functioning with a perfect and terrifying lack of regard for the intentions of the beings that inhabit it. Whether the sky above a small rocky planet is black, violet, or seared white is of no consequence to the fundamental structure of space-time. The Milky Way contains between 200 billion and 400 billion stars, each a massive furnace that has burned for millions or billions of years. Against this backdrop, the few months of Jovian light represent a phenomenon so small it would be invisible to an observer in the next star system over. To the galaxy, the birth and death of the artificial Jovian sun is less than the pop of a single bubble in a vast, boiling ocean. Human ambition, which viewed the three-eye atlas as a pinnacle of achievement, is revealed to be a microscopic tremor in the grand narrative of the void. The question that drove the experiment was a whisper into a vacuum that offers no answers, only the cold persistence of its own existence. The failure of the experiment, the choking of the nuclear fire, and the eventual collapse of the Jovian star is not a tragedy in the eyes of the universe. It is simply the restoration of an equilibrium that should never have been disturbed. Entropy, the measure of disorder, always wins the long game. The energy released by the proton-proton chain in the Jovian core will eventually dissipate. The heat will radiate away into the blackness, and the gas giant will return to its state of arrested development. The universe is a system that seeks the lowest energy state. a machine that slowly cools until all light is extinguished. The brief, violent attempt to create a second sun was a momentary defiance of this trend, a tiny ripple in a pond that quickly returns to stillness. This realization of insignificance is the most profound outcome of the experiment. The human species often views itself as the protagonist of a cosmic drama, believing that its actions carry weight on a universal scale. Yet, the indifference of the void suggests a different reality. The laws of nature, the Eddington limit, the Coulomb barrier, the grand tack, do not exist to serve life. Life is merely a rare and fragile byproduct of their operation. The cosmos does not care if the Earth is a garden or a cinder. It does not care if the night is filled with stars or a violet haze. It continues its slow, inevitable march toward the end of time, 13.8 billion years after the first light and trillions of years before the last, indifferent to the flickering lights of the civilizations that rise and fall within its folds. The Three-Eye Atlas was a needle of dark matter, a spearhead of curiosity, but in the cold mathematics of the void, it was nothing more than a speck of dust. Its failure is a testament to the fact that the universe has very specific reasons for its architecture. The giants are kept asleep not by a protective deity, but by the rigid constraints of mass and energy. When those constraints are challenged, the universe does not respond with anger, but with the simple, mechanical application of its own rules. The collapse of the Jovian sun is a return to the mean, a correction in a cosmic ledger that does not even record the names of those who attempted the change. The silence that follows the flickering out of the second sun is the true voice of the cosmos. It is a silence that has lasted for eons and will last for eons more. In that silence, the entire history of humanity, the ignition of Jupiter, and the potential destruction of the solar system are all reduced to a single, fleeting event in a system that does not notice. The experiment was a failure of physics, but more importantly, it was a lesson in humility. It framed the human experience not as the center of the universe, but as a brief, beautiful, and utterly inconsequential accident. The violet twilight fades, the obsidian night returns, and the universe continues its indifferent grind, unaware that for one brief moment, a small collection of atoms on a tiny world tried to tell the stars how to shine. The king remains on his throne, once again cold and dark, while the void stretches out to infinity, undisturbed by the minor fluctuations of a single lonely solar system. The void remains silent, but the silence is no longer empty, for it is now inhabited by the memory of the light. There is a profound and terrifying beauty in the fact that a collection of atoms forged in the hearts of ancient and dying stars could organize themselves into a form capable of asking why they exist at all. We are the part of the universe that has developed eyes to see the darkness and a mind to measure the depth of the abyss. The Three-Eye Atlas, though it resulted in a flickering failure and a temporary dislocation of the celestial order, stands as a monument to this singular capacity. It was not merely a probe of dark matter and steel, it was the physical manifestation of a question. To ask what lies beyond the threshold of a planet's potential is to fulfill the fundamental role of the human species as the witness of the cosmos. This role is both a privilege and a burden. To be the witness is to understand that the stability of our world is a fleeting gift, a momentary pause in a narrative of violent change that spans 13.8 billion years. We exist in a quiet era, a golden window of time where the giants of our system remain in a state of arrested development. Jupiter sits in its cold, dark majesty, its mass held in check by the same laws that allow our own small world to flourish in the light of a single, steady sun. This realization should evoke a sense of overwhelming gratitude. The Great Red Spot continues to churn, not as a furnace of nuclear fire, but as a storm of ammonia and methane, a silent guardian that keeps the peace of the outer solar system. We live in the shadow of giants that are, for now, content to sleep. The experiment of the Three-Eye Atlas reveals that the most dangerous weapon in the universe is not a needle of dark matter, but the question of what if. This question is the engine of our progress and the source of our greatest risks. It is the impulse that drove us from the caves to the stars, and it is the same impulse that tempted us to crown a king with fire. Yet even in the face of the indifference of the void, there is a nobility in the attempt. To reach out and touch the heart of a giant, to try and understand the mechanics of the stars by recreating them in our own backyard, is an act of supreme courage. We are the only part of the cosmos that turns back to look at itself, trying to decipher the rules of the engine even as we are carried along by its gears. As the violet twilight on Earth finally fades and the true, obsidian night returns, the stars seem more precious than they did before. The constellations resume their familiar places, no longer drowned out by the artificial glare of a second sun. We look up at the Jovian throne and see it as it was meant to be, a cold, swirling masterpiece of gas and gravity. The moons, though seared and changed, continue their ancient dance, their icy shells eventually refreezing in the deep cold of the outer system. The solar system returns to its equilibrium, but the witness remains changed. We have seen the fire, and we have understood the cost of the crown. We have learned that the universe has no need for our intervention to be perfect, but it does need our presence to be known. The journey into the deep mysteries of the cosmos does not end with the failure of a single experiment. Instead, it is merely the beginning of a deeper engagement with the reality of our existence. Each discovery, each hypothetical fire we light in the theatre of our minds, brings us closer to understanding our place in the grand design. We are the cartographers of the infinite, the poets of the vacuum, and the only ones who can give a voice to the silent stars. The story of the universe is still being written, and we are the only ones here to read it. To continue this exploration is to participate in the greatest adventure ever undertaken. It is a path that leads from the subatomic struggle of the proton-proton chain to the vast gravitational architecture of the galaxy. By seeking out these truths, we honour the curiosity that defines our species. We invite those who share this hunger for understanding to join us as we peer further into the dark, to stand as fellow witnesses to the wonders and the terrors of the celestial machine. By subscribing to this channel and joining our collective journey, you ensure that the light of inquiry never flickers out. Together, we will continue to ask the dangerous questions, to look back at the giants, and to wonder at the sheer, improbable beauty of a universe that allows us to exist within it. The stars are waiting, the void is calling, and the story of the cosmos is ours to tell.